In this video, we're going to look at how to differentiate different trigonometric functions using the chain rule. For our first example, we're going to be differentiating the function y is equal to sine x to the power 4. We're going to start off by letting u equal to sine x. This allows us to express y in terms of u, such that y is equal to u to the power 4. We then differentiate u with respect to x, so we have du on dx is equal to cos x. We also do the same for y. dy on du is equal to 4u cubed. Next, we apply the chain rule, which states that dy on dx is equal to dy on du times du on dx. Then we simply replace dy on du with 4u cubed and du on dx with cos x, so that we have dy on dx being equal to 4u cubed times cos x, or just 4u cubed cos x. And for our last step, we just replace the u with our definition of sine x. So our final answer is the derivative of sine x to the 4 is simply equal to 4 cos x times sine x cubed. For our second example, we're going to differentiate the function y is equal to cos x squared plus 1. We're going to start off by letting u equal to x squared plus 1. So now we can express y as being equal to cos u. We then differentiate u with respect to x, so we're going to get du on dx is equal to 2x, and we're going to differentiate y with respect to u, so we have dy on du is equal to negative sine u. We again apply the chain rule, which says dy on dx is equal to dy on du times du on dx, and we're going to replace dy on du with negative sine u and du on dx with 2x, so that this becomes negative sine u times 2x, or negative 2x sine u. And for our last step, we just replace this u with x squared plus 1, and we have the derivative of cos x squared plus 1 is equal to negative 2x times sine x squared plus 1. For our third example, we have got the function y is equal to cos of log base e of x. We're going to start by letting u equal to log base e of x, so y is equal to cos u. Next, we differentiate u with respect to x, so we're going to get du on dx is equal to 1 on x, and dy on du is simply equal to negative sine u. Again, we apply the chain rule. Dy on dx is equal to dy on du times du on dx. Dy on du gets replaced by negative sine u. Du on dx gets replaced by 1 on x. So this becomes negative sine u times 1 on x, or simply just negative sine u on x. And for our last step, we just replace this u with log base e of x. So our final answer is the derivative of cos log base e of x is equal to negative sine log base e of x, all divided by x. Our last example, we're going to differentiate the function y is equal to tan squared 2x minus 1. First, we let v equal to 2x minus 1 and u equal to tan 2x minus 1. By replacing 2x minus 1 with v, we can now write u as being equal to just tan v. Y is equal to tan squared 2x minus 1, but because we define u as tan 2x minus 1, we can now write y in terms of u as simply equal to u squared. Next, we're going to differentiate v. dv on dx is simply just 2. We also differentiate u, but with respect to v, so we have du on dv is equal to sec squared v. And y, we're going to differentiate y with respect to u, so we have dy on du is equal to 2u. And for the chain rule, we're going to get dy on dx is equal to dy on du times du on dv times dv on dx. So we're going to replace dy on du with 2u. We're going to replace du on dv with sec squared v, and we're going to replace dv on dx with 2. So this is going to give us 2u times sec squared v times 2, which cleans up to 4u sec squared v. And for our last step, we're just going to replace the u with tan 2x minus 1 and the v with 2x minus 1. So our final answer is the derivative of tan squared 2x minus 1 is 4 tan 2x minus 1 times sec squared 2x minus 1. Thanks for watching, everyone. I hope you guys found that useful. For more videos on this topic or other topics, please have a look at our channel. We release videos weekly across various maths topics. So if you haven't already, don't forget to subscribe. We would love to see you all in the next one. Bye for now.